Can I
speak
call
with
you? Can I call you Ron or Ronald or Dr. Melnick?
Ron is what my friends call me.
Okay, good. Well, thank you. Now you are. I'm going to read your bio in a moment for our audience, but you basically did this design and you led the $30 million National Toxicology Program study on wireless going back about 20 years is when it was first initiated. So you have firsthand account. This is going to be very powerful information from somebody who actually did the actual science. We're going to get his perspective on the studies, on the science, on the safety standards, and on 5G. So very powerful interview here. I'm glad to be sitting with you, Ron.
Just a point of clarification.
Please.
I led the design. I retired before the studies were completed.
Okay.
But I did participate at the peer review of that study.
Which was 2018?
2018.
Okay. Great. Thank you for that clarification. So Ronald L. Melnick, PhD, is an independent consultant and was a senior toxicologist for 28 years in the National Toxicology Program, or NTP, at the National Institute of Environmental Health Sciences, part of the National Institutes of Health, leading the design and interpretation, as he mentioned, of numerous toxicity and mechanistic studies on environmental and occupational chemicals. He led the design of the NTP's $30 million project, their toxicology and carcinogenesis studies of cell phone radiofrequency radiation in rodents. Dr. Melnick has served on numerous scientific review boards and advisory panels, including those for the EPA and the WHO's International Agency for Research on Cancer, or Iarc, which classified radiofrequency radiation as a possible carcinogen in 2011. And Dr. Melnick also spent 1 year at the White House Office of Science and Technology Policy, working on interagency assessments of health risks of environmental agents. That's a significant background, and it's very good again to be speaking with you on this. So let's dive into this, and I want to understand and just give our audience a clear understanding of what is the NTP study that was originally, that was funded by the government. How big was it in scope, and what was your role in it?
I wonder if I should even step back a little bit further.
Okay.
For the audience who may not know what the National Toxicology Program is.
Please.
Okay. So the National Toxicology Program began in 1978, where the Secretary of Health, Education, and Welfare at that time thought it would be best to combine the various agencies in HEW, which is now DHHS, into one toxicology program where each of them were conducting their own toxicity studies. So the National Toxicology Program is actually a combination of multiple agencies. Right now, that includes the Food and Drug Administration, CDC, and National Institutes of Health, with NIEHS being where the program is headquartered. So it began out of a cancer bioassay program that was being conducted at the National Cancer Institute, and that eventually moved down to Research Triangle Park in North Carolina, and that's where I spent my 28 plus years at the NIEHS National Toxicology Program.
Okay, great, thank you.
Okay, so the National Toxicology Program also accepts nominations for studies from multiple sources, any source. They can come in from agencies. Typically, the major sources of nomination are the National Cancer Institute. It may be Occupational Safety and Health. It may be EPA, maybe FDA, as well as citizens or unions or any group. The nominations undergo review, and eventually those that are selected become under the guidance of individuals within the National Toxicology Program. Okay, so the cell phone wireless radiation came into the National Toxicology Program from the FDA, Food and Drug Administration.
Okay, that's who commissioned this major study.
They requested it.
Okay.
They wanted us to conduct animal studies in order to assess whether there is a risk to humans from cell phone radiation, because exposure guidelines that existed at that time were based on thermal or heating damage to tissues from short-term exposure, and they felt that it was important that we try to understand whether or not there are long-term health effects that might exist from non-thermal exposures. So try to reduce the heating effect. As most people know, this is microwave radiation. If you're exposed to too high a level, it causes heating. That's why we heat our foods in microwave ovens. But at lower levels, where you can minimize the heating effect, and that's what cell phone radiation is, are there health effects that might exist in the absence of that heating of tissues?
Mm-hmm. So you're looking at possible effects that occur at levels far below the threshold of what it's required to heat the tissue, which is what the standards are based on.
Yes.
Okay.
I can tell you a little bit about the standard if you're
Please.
Curious.
Yeah.
Okay, so the standard was developed as a result of exposures. This was done in monkeys, where monkeys were exposed to this microwave type of radiation. And there was a dose, which I'll try to explain, which was 4 watts per kilogram. It's just a numerical value at this time, just to keep it in mind, at which the body temperature did not increase by 1 degree centigrade. So that became the target for cell phones exposures. The value 4 watt per kilogram was divided by 50 to say that this would be a safe dose for whole body exposure to humans, and 4 divided by 50 is 0.08 watts per kilogram. Okay, but there's another standard that goes into that. That is for the whole body exposure. The other aspect is local tissue exposure. So over a 1 gram part of tissue, the exposure could be 1.6 watts per kilogram. These values are called specific absorption rates, or SARs. And if you look into a cell phone where there's a link, I think it's under general information towards regulatory standards, you can find out what is the permissible exposure or emission from your cell phone that has been tested. So that standard is 1.6 watts per kilogram. These numbers become important because they're involved in the design of our experiment.
Okay. Now, can I just ask why is there one number, far more stringent of a threshold for whole body exposure, and then the number goes much higher for a specific point exposure?
I'm not sure exactly why. The whole body, as I said, was based on a temperature rise, a whole body temperature rise. I think if you're exposed to walking by a cell tower, for example, or you're close to a cell tower, your whole body is exposed. But if your whole body is exposed, it's that tissue level, which may see a higher level as long as your whole body is within that limit. But I want to explain one other thing about that, is the importance between the 1.6 and 0.08, because this is very important, because the NTP studies were focused on the 1.6 watt per kilogram. And the reason was is where the antenna is. The antenna is emitting the cell phone radiation. So for example, if this was an antenna, if I held it next to my head, say this was a cell phone, if I held it next to my head, the tissue that is being heated is the tissue that is right next to the antenna. So what I'm concerned about is that 1.6 watt per kilogram in that tissue. If I divide that by my whole body weight, because now I'm linking it to my ankles, my calves, the rest of my body, that would dilute out the effect of the exposure to the local tissue. So there's a local SAR of 1.6 watt per kilogram and a whole body of 0.08. In designing the NTP study, I was most concerned about the 1.6 watt per kilogram because that is the permissible exposure.
Got it. Okay, so you're on the 1.6 milliwatt per kilogram?
It's watt per kilogram.
1.6 watt per kilogram, which is based on the SAR standards, the specific absorption rate standards. What is the permissible threshold for microwave radiation from a cell phone with pertaining to the tissue next to it? So that's based on just the heating standards. Okay, right. So please continue.
Okay, so the experiments that NTP did were in animals, and you cannot measure SAR in live animals or in people. There's a modeling effort that goes into that. So the cell phone itself, when it comes up with a value, is based on the antenna next to a simulation fluid, a fluid that has properties similar to tissue. And from this, that modeling effort comes up with a value. And it depends on how close the antenna is to the tissue, because the further away the antenna is, the decrease in the power by the square of that distance. So if I double the distance, the antenna from my head, the power level is 1/4 instead of 1/2. Okay, so the NTP does studies in animals. And why do we do studies in animals as opposed to people? Okay, well, first of all,
ethics.
That's one of the reasons. Another reason is that many of the processes of disease occur similarly in animals as in humans. Every known human carcinogen is also a carcinogen in animal studies that have been conducted properly. Okay. Another reason is that there's the issue of confounders when you do human studies, that you're exposed to one source, but then there's other environmental exposures that also occur. Was it due to the particular source that you're focusing on, or was there a contribution from other confounders? With a animal study, we can very carefully design a study to quantify and really measure that exposure in the animals. And then lastly, if there is an effect, hopefully the agencies, the regulatory agencies, would make use of that data to reduce exposures to the extent that we're reducing risk, because cancers can have a long latency, and it may be 30 years before we really know whether or not something is safe, as opposed to an animal study, which you can conduct it in much fewer years.
Okay, so was it a 20-year study, correct? And was it with 2G and 3G radiation? Can you just confirm?
Okay, the study took about 20 years, but the actual chronic study of the exposure of animals, because it's a multi-phase study, the animals were actually exposed in the cancer study for just over 2 years, approximately 2 years.
So 2 years of collecting data, is that right?
2 years of exposure. I can go through a little bit in terms of the various steps in the process.
A brief overview, please. Yeah, that would be helpful.
Okay, so the the actual exposure for the cancer is 2 years. But in terms of design of the experiment, and this is where I was leading this effort, comes in terms of how do we do an animal study with cell phone radiation? You know, obviously you may see cartoons with little cell phones on animals, but in reality, we needed a way in which we could expose animals to the radiation without disrupting their normal lives. There had been some studies which had been done on this type of radiation, and at the time, we felt that this was inadequate for understanding whether or not there was an effect. Remember, at the time that the study was conducted, there was the assumption, and this is important, that the only effect from this type of radiation would be heating, because this is non-ionizing radiation. It doesn't break chemical bonds. So we wanted to challenge that hypothesis. Is there an effect that is not due to heating? And if there is such an effect, can we collect enough information for what we call dose response analysis so that we can sort of quantify the risks? Because in an animal study is relatively insensitive. We're dealing with typically 50. This one, we had 90 animals per group. But in a study of that sort, you don't reach statistical significance until you see at least a 5% increase over the control rate. Now 5% rate in the human population would be epidemic. And, you know, so animal studies are typically done at much higher exposure levels than humans experience, and through a dose response analysis, we try to estimate what is the risk at lower levels. So obviously 5%, 10% risk is unacceptable, but what is acceptable? Is 1 in 1,000 risk? What, considering how 250, 300 million people in the US have cell phones, 1 in 1,000 is a lot of people. What about 1 in 100,000? What about 1 in 1,000,000? These become difficult questions in terms of what is acceptable risk. It's something that actually the Supreme Court addressed in the 1980s. What is acceptable risk? I don't know if you want to hear their conclusion.
Sure. What did they say?
Okay. They said, they punted a little bit. They said, if the risk is less than 1 in 1,000,000,000, it's insignificant. If it's greater than 1 in 1,000, it is highly significant. So they left a big gap between 1 in 1,000, 1 in 1,000,000,000. EPA adopted 1 in 1,000,000. OSHA, the Occupational Safety and Health Administration, adopted 1 in 1,000, which is quite different. But in any case, we want to know what is that risk, because if you understand the risk, you can then make efforts to try to reduce the risk, either through modifying the device or taking other precautionary measures.
Okay, so before we get into the findings, I just want to confirm, this was with 2G and 3G technology, is that right? And was it with mice or rats, or what animals were used?
Oh, well, we used mice and rats. The main effects were seen in rats. Okay, and it's basically 2G, but a lot of the 2G is still relevant to 3G.
Okay.
It's just faster. So in terms of designing this study, and this is why it took a long time, I contacted engineers and physicists at the National Institute of Standards and Technology because a different group there had helped us in terms of wire radiation, the very low frequency radiation. And I spoke with an individual there. His name was Perry Wilson. And we started discussing this concept of reverberation chambers. And we tested the feasibility of doing an experiment in a reverberation chamber. Now, a reverberation chamber is a room, but it's like a big microwave oven. And within that room, you have an antenna and the antenna is emitting the radiation. And then within that same chamber, there are paddles of which the radiation is actually bouncing off in all sorts of directions. And over time, a short time, it creates a homogeneous environment of this radio frequency radiation. So we wanted to consider doing our experiments of animals in a reverberation chamber. So we needed to demonstrate that you could create a homogeneous environment such that animals located in one part of the room would receive the same radiation level as an animal in a different part of the room. It took a while to develop this. We then interacted with a group in Zurich, Switzerland, and we got involved in modeling the nature of the absorbed dose in animals and in their specific tissues when exposed in reverberation chambers. So they developed this modeling effort to quantify at the frequencies that we used what would be the level of absorbed dose. So the frequencies that we used were two frequencies, 900 megahertz and 1800 megahertz, because these were the center of the frequencies used for cell phone communications.
Is that 2G and 3G respectively?
Yes, I believe these are still being used. Yeah, in the 3G, and I'm not sure. I think 4G is also. 5G is going to be very different.
Yes, yeah, it's a range of
5G is a much higher frequency.
Yeah. Okay, so let's dive into the findings now. What did you discover?
I just got to do one more thing in terms of justifying
I'm a bit impatient, but I'll let that go because you're establishing a very important foundation here before we get into the findings. So please continue.
That's what I'm trying to do. Okay, so if you recall, we wanted to do this where we considered heating wouldn't be the effect. So we did what we called a thermal pilot study, in which we exposed animals to various power levels and had temperature measurements taken because we wanted to keep the body temperature rise to less than 1 degree centigrade, because that's the basis for the cell phone regulation guidelines. Okay, we found for rats, instead of 4 watts per kilogram, you could go to 6 watts per kilogram. Okay. That ultimately became the highest exposure that we used in ours. Now, as I mentioned a little bit before, when you're doing a toxicity study, you typically go much higher and you do a quantitative risk assessment and extrapolate down to lower. But we couldn't go higher than 6 because 6 would start to create the heating effect. Okay, so the first thing to do was to establish what is the highest level. We also used 2 modulations which have been in use. One is GSM, which is Global System for Mobile Communications, widely used in Europe, and I believe 2 of the networks in the US. I think it's AT&T, and I'm not sure if it's T-Mobile or not. Use GSM. And the other was the CDMA, which is a code division for multiple access. These are modulations that allow many individuals to get access to the network. Okay, so we included both GSM and CDMA in our studies. So to increase the power of the study, we increased the number of animals. Typically, an NTP study has 50 animals per group. When we went to the chronic study, we increased it to 90. And the highest exposure now was 6 watts per kilogram. We also used 3 watts per kilogram and 1.5 watts per kilogram. So essentially dividing the dose in half, such that if there was an effect, it might be possible to do a dose response analysis for a quantitative risk assessment. And for rats, to increase sensitivity, we included rats from pregnancy on through delivery and then 2 years. Okay, a typical NTP study is 2 years after their 2 years, starting at around 6 weeks of age. Okay. Let me just explain one other thing in terms of the reverberation chamber, because I think it's also important. because in a reverberation chamber, the animals are free roaming in their cages, which was important since previous studies had animals constricted in tubes during their exposure. Also, in previous experiments, animals couldn't have access to water, and therefore the exposure periods were limited to 2 hours per day. We wanted to increase that exposure duration since we couldn't increase the exposure dose. And we worked out a way in which animals could receive water during the exposure. Now, you can't just put a bottle in there because the bottle of water would absorb the energy and heat up. You can't shield the bottle and just have a sipper tube because the animal that tip of water would also heat up and you could get some sparking between the animal when they're drinking. So built into the design, there was an automatic water system with a little choke on it so that the animals could get water without that tip of their head exposed to the radiation. Okay, so the study went on for 2 years after delivery, and in rats there were multiple effects. Some of the effects that were observed were increases in schwannomas of the heart. Schwann cells are the cells that create that myelin sheath around the nerve. Okay, that was one of the type of tumor effects in male rats. The other was a glioma. This is a brain tumor, was also observed in the exposed animals, not in the control animals. So we had, for rats, we had a control group, exact same chamber. The stir was present. There was even an antenna there, but there was no power delivered to the antenna. The other groups, under the exact same condition, had various levels of power delivered such that during the course of the study, we could maintain 1.5, 3, or 6 watts per kilogram for animals. So as they grow, the exposure intensity could increase, but the actual SAR dose was remaining constant.
Okay, so you discovered the findings were schwannomas of the heart, which is that a malignant tumor? Can you?
Yes.
Okay.
Yes.
And then gliomas in the brain. Is that correct?
That is correct.
Okay.
In addition, when looking at effects in terms of making a decision, how strong is the evidence? There an uncommon tumor that you don't see very often in control animals takes a little more precedence over something which has a high background. So when you see small number increases, but if it's against an uncommon tumor that you hardly see in the program, that has much more relevance.
And are schwannomas and or gliomas uncommon? Is that
yes?
Okay.
Yes, these are uncommon.
Now you mentioned that the Supreme Court said between 1 in 1,000 and 1 in a billion, somewhere in that gray area is right. Say the threshold. OSHA says 1 in 1,000 increase, and another EPA says 1 in a million. What are the numbers in terms of the NTP study? How much did it increase in those 2 cancerous tumors? Well,
you can only answer that question if someone will do a risk assessment with the data, and that hasn't been done. The intention of this experiment, it was a nomination from FDA so that a quantitative risk assessment could be done. And if a quantitative risk assessment could be done, that information then would be provided to the FCC, who sets the guidelines. And the intention would be to develop health protective guidelines as opposed to guidelines based on the assumption that it's been reduced and there's no heating effect. The quantitative risk assessment has not been done.
In other words, the FDA, who asked for this study to be done, it got done. There were significant findings showing increase in in cancerous tumors. And then what happened? It got dropped, or what's been the impact of these findings, and are you satisfied with the impact that it's had?
Well, I'm not satisfied, that's for sure, because the FDA said we can't apply this information to humans.
Why?
Well, they didn't give a reason. They just made that statement. The director of radiological devices, wireless devices, just made the claim this is not applicable to humans, which actually makes no sense since FDA nominated it so that we could do a quantitative risk assessment for humans. So FDA has essentially shirked their responsibility and did not fulfill the intention of their nomination.
Now, you wrote an article in The Hill last November in which you said the FDA reasoned that, quote, existing exposure guidelines are based on protection from acute injury from thermal effects of radiofrequency radiation exposure and may not be protective against any non-thermal effects of chronic exposure, unquote. And you said, by adopting this new position and ignoring the NTP's results, the FDA's, like you said now, clearly shirking its responsibility of assessing the impact on human health and radiofrequency radiation. So are they, I mean, we could go in a couple of different directions here, but just the understanding, the significance of that understanding that approximately $30 million was invested to see if cell phones cause cancer at levels at or below the allowable levels, right? In rats. And the answer is that there was a significant increase in schwannomas of the heart and gliomas in the brain, and then they just dropped it. So, I mean, I guess I want to ask the question, like, why do you think? Now we're getting into speculation here, and we know that Harvard, ethics department has written about the FCC's, being controlled by industry, but the FDA, we've heard in other conversations various things about them. But like, what's actually going on, and how significant of a thing is this, Ron? That the study was done, it showed cancer, and then they just dropped it. Help us to frame this here.
Well, I can't tell you why they decided as such. All I can say is that they decided at this point, or as far as I know, not to do anything about this. This information was actually available in 2016 when the NTP released some of the partial findings because of the potential impact of these findings on the general population. The tumors in the heart and tumors in the brain were known in 2016. It could be that they don't want people to think that their cell phones pose a cancer hazard. Maybe they have other reasons, and I can't say whether or not the industry is having an influence. That is certainly a possibility. But it seems to me that from a public health perspective, what you'd want to do is understand the risk, quantify it, and do something about it. Promote precautionary principles, at least for people. Right now on many of the sites, they make the statement, if you are concerned, you can do this. Well, as a general citizen of a person who uses their cell phone, they may say, well, if the FDA isn't concerned, why should I be concerned? If the FCC isn't concerned, why should I be concerned? To me, they should have at least said, this is what you should do because of these results while we are determining the risk. This would put a little more pressure on the industry to reduce the amount of emission that's being delivered from the phones. Now, the industry has done some improvement over time on their cell phones. So as I was mentioning before, It's the location of the antenna, which is emitting the radiation. Where that is located makes a big influence in terms of the dose that is received by that local tissue. So the antenna has been moved from right next to your ear to the mouthpiece. So it's lower, and it does provide a little bit more distance. But it depends on how people use their cell phones. To me, at least provide certain recommendations, just sensible recommendations. People are texting more, which is good, because they're not holding the phone next to their head. Do people know that when the signal is weak, and you can see this on your phone, the number of bars, when the signal is weak, the phone is trying harder to maintain good communication. So it's emitting more power than when you have a strong signal.
In some cases, thousands of times more. I've actually tested it with my Cornet electroshock meter. It's shocking on how much the radiation from your phone goes up if you have only 1 bar or even 2.
Right. So most people don't know this.
Yeah.
And the FDA should be promoting this kind of information as opposed to just saying, we're going to ignore it.
Okay. How else should the FDA and the FCC respond to and use this NTP data? What should they be doing?
Well, they should be doing a quantitative risk assessment.
Yeah.
We should be able to work through what are the exposure levels, which would be exposure and duration of exposure that are associated with a cancer risk of 1 in 100,000, for example. If that is a risk, if people knew that their risk was, say, 1 in 1,000 for speaking an hour a day, a year, and I'm just making up numbers. If they knew that their risk now was 1 in 1,000 by holding a cell phone next to their head for an hour a day, they might say, well, I don't want to accept that risk. And they would do something. There's another aspect for children, which I'm also concerned about, because the radiation penetrates further into the brain of a child, and the brain is more susceptible to tissue damaging agents in a developing brain. But there are many toys that are being developed for children which are of a concern, because the children don't know whether they lick the phone or a different device which is similar. This should be limited. It should be, if you don't know the risk, it's hard to understand how people will react. If they understood the risk and FDA made recommendations where, for example, we're working to try to reduce the emission level, but in the meantime, take these recommendations, when you're on an elevator and you're down to 1 bar, maybe that's not a good time to be on the phone, as opposed to just disturbing other people who are on the confined space with you.
Yeah. It seems to be about liability, isn't it? I mean, maybe this isn't your expertise, your area of expertise, and considering things like this, or reasons that the industry and government is doing this. But it seems like if they were to say, when you're on an elevator or when you have 1 bar, don't put the phone next to your head, then that would That could, maybe from their perspective, they're concerned about causing a panic, but really they're concerned about liability once this thing, reaches a certain level of threshold, right? Like, isn't there a reason why Lloyd's of London and certain large insurance outfitters don't insure wireless companies' products?
I hadn't thought about that, but it makes sense.
Yeah,
certainly.
So you've done also
Let me just mention,
please.
There were a couple of other effects besides the tumors.
Okay.
There was also a disease of the heart called a cardiomyopathy. It's a disease of the muscle tissues in the heart, which showed a very clear dose response. There was DNA damage in the brains of rats, and a number of mechanistic studies have been done since the Iarc evaluation in 2011. and might be providing clues in terms of why there is now observable DNA damage occurring in brains. In addition, as I mentioned, the rats were exposed during gestation in utero, and there was a reduced body weight of the pups. So there's other effects which appear to be going on. And basically, when you see these types of effects, we now know that that first assumption that the study was designed to challenge, that assumption is wrong. The assumption that the only effect can be heating of that tissue is wrong, since we tried to control the temperature effect to the extent possible. So seeing multiple effects says that we can't rely on assumptions now when we're talking about wireless devices.
Yeah, very good. And we, in the early 70s, Zori Glaser put together for the U.S. Navy research there 2,300 studies with 5 pages of effects from microwave radiation, right, at various intensities, it must be said. But that I mentioned that in my film, Take Back Your Power. Now, my question is, so you looked at several effects and you noticed several effects from this NTP study. What about, all of the other possible effects that weren't looked at, and you can surmise that this type of exposure of microwave radiation affects life, affects biology in multiple areas. So I just want to turn focus to your role with you have done considerable work with the Iarc panel. That's for correct. The WHO. And I wanted to ask also, what impact did the NTP study have on Iarc? And also, could you summarize briefly your role of work that you've done with the Iarc panel?
Okay. So, well, the Iarc panel met in 2011. So the NTP data weren't available.
Okay.
So at that time, the Iarc panel, you probably know, came up with a determination that radiofrequency radiation was possibly carcinogenic to humans. Now, this Iarc has a certain type of process that most people probably don't understand, aren't aware of. They invite people from worldwide to come to Lyon, France, to prepare what they call a monograph. It's basically a book. And for the cell phone or radio frequency radiation, as with chemicals, they divide the people into 4 groups. One group looks at the exposure and emissions. One group looks at the animal cancer studies. Another group looks at the available human studies or the epidemiology. And the 4th group looks at mechanistic information that was available at that time. Iarc had sponsored what was called a multinational agency, a multinational evaluation of cell phone radiation under the name Interphone. That had a big impact on the discussions at the Iarc meeting. In addition, there were a number of studies done by the Swedish investigator Leonard Hardell, who had also reported numerous studies in which they found increased brain cancer risk, which were glial tumors. They also found schwannomas of the nerve over the sheath of the nerve near the ear, which shows a concordance between the NTP studies and the human studies. Now, there are different kinds of. At that time, the animal studies were considered limited. There weren't adequate studies in conventional models. There were a couple of what they call initiation promotion studies or co-carcinogenic studies, which showed a positive effect, but it was very limited. So limited, see, Iarc has terms. Limited means that the information wasn't convincing in animals. The human data was also considered limited. And the reason for this is that there are different types of human studies that had been conducted. One is case control studies. A case control study is one in which you, for example, have people who have a particular tumor or have died of a tumor, have a particular type of cancer. You look at this population, and these may be hospital-based, and you match the characteristics of that population with a population that doesn't have that type of cancer. So you match them by gender, by age, maybe other factors. The Interphone study and the studies by Hardell were case control studies. The issue that came up at the meeting was a case control study might have a bias because you're now asking people or their descendants on the use of the phone by the person who has the cancer, and they design the questionnaire to try to not focus on just the one issue, but there may be a bias in terms of a person saying, "Oh yeah, he used the cell phone on that side of the head, and that's where the tumor occurred." So there is that potential bias. The other kind of study are what are called cohort studies, where you're looking at a large population and you're trying to see within that large population, is the tumor rate higher in those who use cell phones more compared to the population that doesn't use cell phones or uses it much less. Now, these kinds of studies were negative, but they have big problems in terms of the classification of exposure. So, for example, if you're looking at a large population, thousands and thousands of people, they sometimes go to their phone records. A phone record may not actually reflect the use by the individual who has the subscription to that phone. So the cohort studies were negative. The case control studies, the Interphone at the highest exposure level was positive, as well as the Hardell. The Iarc panel came to the conclusion then that the information for humans was their term limited. Limited doesn't mean not an effect. It means that there was a causal interpretation is credible, but you couldn't rule out chance, bias, or confounding to a reasonable extent. And therefore it was left at limited. So when you have a limited human, limited animal, the Iarc groups that together as a possible human carcinogen. A limited human and a sufficient information in animals would be a probable human carcinogen.
So is there a movement among scientists, the scientific community, to reclassify radiofrequency radiation as either a 2A, probable, or a group 1, a definite carcinogen?
Well, there have been more studies by Hardell as well as others. In France, there's another positive study for gliomas. Mm-hmm. There's a nomination process that goes to Iarc for studies being requested that are evaluated in the near future. They do these on 5-year intervals. Mm-hmm. As far as I know, the radiofrequency radiation was discussed, and it is in the plans for a reevaluation. I don't think it's fair to say a push by people to call it known or push to call it something, because mm-hmm. it's an evaluation process in which, in the case of the 2011, there were about 25 people. There's judgment involved in all of this. I have my own belief in terms of where it might fit right now, but others might believe differently. Okay. It's a scientific debate among the experts at the meeting who come up with a conclusion.
Okay, good. This is really good. I want to cover some more ground here as we move towards wrapping up the conversation. So really quickly, you mentioned that the FDA is shirking its responsibility by acknowledging and responding to the data of the $30 million NTP study. Is the WHO, the World Health Organization, also shirking its responsibility here?
I think they're going through their process. It takes a while to bring together all of that information to get a panel.
Okay.
So it's on as far as I know, it's on schedule. Well, I don't know if it's scheduled, but it's in the plan for the next 5-year interval to reevaluate radio frequency radiation.
Okay. But meanwhile, switching to 5G now, industry is pushing in the deployment of 5G, as we know, in the United States and around the world, without having done any studies that show safety and without even a plan to do any studies. I am pretty strong in my understanding that that's because they know what they're going to find if they look closely enough, if they actually do a study. So how big of a concern is it to you that this is happening, and if so, why?
Well, I'm concerned for multiple reasons. One is, as you just said, we're bringing back the concept of assumption. Without data, there's the assumption, okay, this will be safe. And we should have learned the lesson on radio frequency radiation used for cell phones, that assumptions are not necessarily in the best interest of public health. Mm-hmm. So I say there needs to be a demonstration of safety as opposed to just a declaration of safety. In fact, there was a Commerce Committee meeting on 5G in February, and Senator Blumenthal raised this question and was looking for assurance that this was safe. And he was told, well, there's no consistent evidence of harm, but there's no studies.
Yeah.
So obviously, if you have no studies, you can't show evidence of harm, but you also can't validate the assumption that it's also safe. So to me, that is a problem. The other issue is the antennas, the way the 5G works. They don't transmit very far. They don't transmit through structures, and therefore they're going to be located in neighborhoods very close to each other. From what I hear, it's in the range of 200 yards to 300 yards maybe apart for an antenna, which will be on a lamppost, not far above ground, so that people just walking in their neighborhoods, if you're in a city, walking by lampposts, you're walking near these antennas, which are emitting this type of radiation for which we know little about its effect. Now, the 5G doesn't penetrate the body to the same extent that the radio frequency radiation does. Okay, and they talk about, okay, so it's absorbed mostly in the skin. But when you're out, remember I was talking about confounders. When you're out in the environment, you're exposed to more than just 5G radiation. You're exposed to UV radiation on a sunny day. So if UV radiation is involved in the development of melanoma, what happens when you now add 5G radiation and UV radiation together? Now, we can say, well, we're going to assume no effect, or we're going to test that hypothesis and demonstrate that there is no effect. What about your eyes? When people are walking by near these antennae, is there any risk to eyesight, any damage? I don't know the answers, but no one can tell me that they have the answers because the experiments haven't been done. So yes, I'm concerned that when we expose something across the general population without understanding risk or the health effects, I would be happy if there were no health effects, but I'd be happier if I knew that there was evidence demonstrating no health effects as opposed to just claiming it.
Yeah. And so, and we know from Deborah Davis and others that we're talking with in this summit that there are independent studies on millimeter wave radiation that do show biological effect, and to a very serious degree in some cases. And there is an indication that the effects could be penetrative into the body. One study is about the sweat ducts and how the sweat ducts could act as helio coils and antenna to transmit that energy into the body and cause effects deeper in. And Martin Pall also talked about another mechanism that millimeter wave can cause effects deeper in. So yeah, very concerning, obviously, here situation. Let me ask you, just as we kind of wrap up here, what would it take, in your perspective, to shift the paradigm, the way that things are done, from industry free-for-all, claims of safety with nothing to back it up, and they just, for profit, just pushing, ramming it forward, to either, you mentioned precautionary principle, like isn't recognized in some other countries in Europe, or the weight of evidence principle. Maybe talk about that, and what do you think would be required there?
Well, it's a tough situation right now because 5G is also political.
Yeah.
And in the political environment in which we exist, we're in competition with the Chinese, and they're going to develop 5G, and we got to beat them to it. The politics is also controlling what's going to happen. Denying local cities their opinion in terms of whether towers are placed within their community, you can't do that. This is something which they're just saying it can be done, it's safe, and we're going to do it. I think the science needs to be done, because the characterization of 5G isn't even complete. We don't even know, when we say 5G, what is it that will be transmitting from those antennas exactly? What is the characteristics? All we know is it's 5G, it's going to be high frequency. Is there more to it? How do you test something when you don't even have the characterization of what you're testing? So this, to me, what would be best would be, rather than getting into these, this is safe, this is harm, bring the industry and the scientific community together to say, we want to deal with this issue. We want to be health protective. What should we be doing in order to know that we're not increasing health risks by the implementation of these new antennas in neighborhoods? So it becomes this side versus that side. And when the politics favors one side, they win. So when the FDA says we're going to ignore the radio frequency radiation study of the NTP, there's no pressure being put on them, as far as I can see, other than myself and others speaking out against it, to do something. But the government has remained silent, and if they were to do something and showed a risk, that might raise concerns for the industry or the government or the FCC. If RF poses a risk, what are we doing with 5G? And they don't have an answer.
Yeah. So we really need, what you're saying, the next step in responding to this incredibly important study that you designed, the NTP study, is a risk assessment by the FDA.
That's the first step.
That's the first. That's
with a simultaneous recommendation.
Yeah.
In the meantime,
okay,
to take precautionary steps.
Okay, and include 5G frequencies, and they need to expand the focus, do the science, and for that to happen, that needs people power. Like you said, it's you and several others speaking out against them, but we need to have people putting pressure on these agencies that are run by commercial interests, unfortunately, and also liability actions to hold them accountable. There needs to be accountability and liability.
Unfortunately, the way our system works is when the regulatory agencies don't act, decisions get made in the courts. And it's litigation, which sometimes forces an issue that is ignored by the government. And this has happened for a number of chemicals. And I'm not involved in litigation on radio frequency radiation, but I understand it's in process for people who've developed brain cancers. to me, that's not the way in which health protection should be accomplished. Be better if the government, scientists, and regulatory agencies and the industry work together, saying we don't want a problem. How can we avoid it?
Yeah. Thank you. Dr. Ron Melnick, thank you so much for your time today and your work over the years as a scientist, and for helping us to frame and contextualize this problem and gear towards solving it. So thank you again.
Well, I do hope that there is some solution at the end. And oh, by the way, as one other person who I don't know if you've interviewed or whether he would be interviewed, is have you spoken to Senator Blumenthal? Because he raised the question and never got an answer. Has he gotten an answer since then? Is he pursuing it? Because like we were discussing before, it's people rising. Once you have a senator, that adds a little bit more strength than individuals who understand a little bit of the science. It would be interesting to hear if Senator Blumenthal would answer some questions from you.
We haven't been able to establish connection with him yet, but that is a very good idea. And we haven't heard back yet, basically. But
I hope he joins.
Yeah. Thank you.
Sure.